the equation of a circle in the xy coordinate plane. So how can we come up with an equation that would distinguish this circle that I have shown here versus some other circle elsewhere in the plane? Well, we're going to need to come up with an equation that's going to give a relationship between the radius, as we know the radius defines the circle, and its center point, because the center point is going to pinpoint its location. So we could have the same exact circle elsewhere. So two circles with the same radius are congruent, but the center point is going to come into play for these types of equations because we want to know its location in the xy coordinate plane. So can we come up with an equation that relates the center point and a radius? So let's call this center HK, which is the traditional notation or letters used for the center of the circle. Now, if some point on the circle is chosen and we extend a radius to that, we're going to call that point just some point xy. Okay? Now, here's what we know, and this is going to be important, and I'll make sure I reiterate this at the end. H and K are fixed, right? They're not going to change. So therefore, they're going to be constant values in our equation ultimately. And the radius of the circle is always fixed as well. So this length r here, which is ultimately what we're going to determine, is also going to be a constant value in our equation because for this particular circle of radius r fixed at this center point hk, the value of that radius is not going to change. And if it does at various points through a rotation, then we no longer have a circle. Okay? However, the point xy, x and y are going to be variables because that point that I've chosen there is of no particular significance. I could have picked any other point to extend the radius to, say over here. Okay, so that point could change, and therefore it's going to remain as two variable terms within the equation. So center is fixed, so it's going to be a constant. It does not change. Radius is fixed, so it will be a constant. But the point on the circle that the center extends to form the radius could change. So therefore, those two values will be variables. Now, how do we figure out an equation that relates these 2 points in order to form the radius? So the radius defines the circle. So if we can come up with an equation for the radius, we have just written an equation for this circle. Now that line that I've drawn there, the radius is clearly the distance between those 2 points. So that's what we're going to do. We're going to write an equation that calculates the distance from the center to a point on the circle, which would be synonymous with the radius, and we know a radius defines a circle. So how do we find the distance between 2 points? Let's form our right triangle. We form a right triangle in the coordinate plane because we can calculate the horizontal distance between 2 points. It's just going to be the change in the x-coordinates, because the x-coordinates tell you how far you've moved away from the origin in a lateral direction. So to figure out that horizontal leg, it is a matter of the difference between the x's. So because we're ultimately going to square this through Pythagorean theorem, it does not matter what you subtract from what, but if you want to be careful, you can take the absolute value of the difference. That will tell you the distance between those 2 points horizontally. Then to get the vertical leg, we want the distance between the center and that point on the circle from a vertical perspective, in which case that would be the difference between the y coordinates, because the y values tell you distance from the origin in a vertical direction. So again, ultimately, due to the fact that we're going to square this term, it doesn't matter what you subtract from what, but absolute value gets you the distance between 2 points. So now that we have the representation for the horizontal and vertical leg of our right triangle, we can come up with a relationship between these 3 parts of the triangle through Pythagorean theorem. We can say that the radius squared should be equal to the absolute value of x minus h squared plus y minus k squared. Okay, this is just Pythagorean theorem. We have c squared equals a squared plus b squared. Again, x minus h is horizontal distance and y minus k is your vertical distance between the 2 points. And why are we doing this again? Because if I can figure out an equation to calculate a radius, I have just figured out an equation for that circle. But we need to use that particular center point. That way we are looking in the correct location on the coordinate plane. So I can't pick any old center point that I want. Once we indicate or pinpoint the location of the circle, h and k are going to remain fixed and constant in the equation. So there's our equation for the circle. I can take away those absolute values because we're squaring those terms. And this is the equation for a circle in the coordinate plane, where your center, we know, is hk, and the radius is, I should say, r, but this is going to be the square root of whatever that number is at the end. Okay? So for instance, let's say, just an example real quick, you have a center of -1, 4 and a radius of 6. If you know this is called standard form for the equation of a circle, by the way. If you know this is your general equation, x and y are going to remain as a variable because they just represent some point on the circle which could change, right? There's an infinite number of points on our circle. So due to the fact it could potentially vary, we leave it as a variable. The center is fixed to distinguish this circle from another of the same radius. So if we do minus h, this is our h and this is our k, it's minus a negative, so it's going to become plus 1, and then minus the k value, which is 4, the radius squared, which is 36. So this is what you would want to present as your equation for the circle, given that radius and center point. Now, working the other way, if you have the equation for a circle, if you had to identify the center and the radius, knowing your standard form, you know that whatever subtracted from x is your h value. So when I see a plus, it's typically minus h in standard form, so that would indicate that my center x coordinate is actually a negative value. So our center is going to be -2. There's no k value associated with the y term, so k is 0 in that case. So our center is at -2, 0. And this is where people get tripped up all the time. Remember that this equation is supposed to be the radius squared. So we know the radius squared is 42. So how do we get the radius? You have to take the square root of that term. So our radius in this case is the square root of 42. So just be careful. Don't think it equals just the radius. It is the radius squared. And the reason why you should be able to identify that is if you understand that this equation was derived from Pythagorean theorem, you can think of it as a squared plus b squared equals c squared, and that will remind yourself that constant term on the other side of the equation is squared. So to derive the hypotenuse length, which is equivalent to the radius length of the circle, you must take the square root of it. So there's an introduction to the equations of circles in the coordinate plane.